Hello, today we continue solving problems using the concept of quantity of matter. The problem we propose to solve today will look like this. The volume of organic matter of methane gas is given. Methane is a part of natural gas, which is used for combustion. This volume is given in 67.2 tenths in liters under normal conditions. In this case, we need to find the mass of methane, the amount of methane matter, and the number of particles. Well, first, let's remind ourselves that we have formulas that allow us to do this. To find the mass. The formula molar mass related to the amount of matter works. To find the number of particles, we need to use the formula N is equal to Na, in this case also multiplied by the amount of substance. Well, the amount of substance itself we have to find from the volume, so we will need to recall one more formula, which works through volume V equals Vm times N. So to begin with, therefore, we will use the calculation of the quantity of matter. As you can see, this is the concept that is the link between all quantities in chemistry. So first, let's find the amount of matter for methane. This action will be the first one. To find it, and we are given the volume, we will proceed as follows. We divide the volume by the molar volume. Let's do the substitution. We've got 60, 7 and 2 liters, and the molar volume under so-called normal conditions is a constant value and is equal to 22 and 4 liters in relation to the mole. In this case, the liter and liter will be reduced. 67 and 2 by 22, and 4 will give exactly 3, and we get 3 moles. Okay, action 2. Now we can find the mass. In order to find the mass of our methane, we will use a formula that relates exactly the amount of substance to the molar mass and to the mass. To do this, we'll use the formula molar mass times the amount of substance. We'll find the molar mass right away. It will be 12. It is the atomic mass of carbon plus hydrogen 1 times 4. Because hydrogen is 4, it's all in grams to moles. And all of that has to be multiplied by 3 moles. The mole and the mole will reduce. The value that's in the calculation here of the parenthesis is 16. So we get 16 times 3. That would give us a total of 40. 8 will be in grams. Let's move on to the last step. We need to find another number of particles. Here we found the number of particles, the mass, and in order to find the number of particles, we need them multiplied by the number of Avogadros by the number of moles. And are multiplied by the number of moles, but the number of Avogadro we have to know by heart. It will be 602 times 10 to the 23rd. The dimension of this number is mole minus 1 and multiplied by 3. Mole. Mole and mole are reduced and our number is 1806. Times 10 to the 23rd. But we can convert that number to 1/806. Times 10 but to the 24th power. All the answers are found and we use just our wonderful formulas that allow us to make this calculation. And the formulas must necessarily know well what is deduced from what formula and how, and moreover to know well the reference data, and this is the molar volume and respectively the number of Avogadro, because these are values that should be well remembered. Without them, it is impossible to solve such problems. I hope it is clear, and that's all for today. Goodbye.